Assalamualaikum and hello everyone. My name is Nur Uzmara Shika binti Nomas Randi, together with my partner Danella Danel, and today we will be presenting about on how to do the calculation that are related to know the types flow of fluids. We are required to select one question from the list provided and complete the given task. As for our group, we choose to do question 17. According to question 17, a 245mm diameter pipe carries water of 0.175 meter cube per second. The specific gravity and dynamic viscosity of the fluid are 0.78 and 0.25 Newton second per meter square respectively. Determine the fluid velocity, Reynolds number and type of flow.
First of all, we need to list out all the information given. From the question, we know that diameter is 245 mm. Discharge through a pipe is 0.1275 m per s. Specific gravity is 0.78. Dynamic viscosity is 0.25. Then the question asks to search for velocity, Reynolds number, and type of flow. For the calculation, first step we need to make sure all the unit SI is correct. For our question, only the diameter is in millimeter, which is not the correct SI unit for length. So we convert it to meter from 245 millimeter divided by 1000, since 1 meter equals to 1000 millimeter, and finally get 0.245 meter. After all unit conversion has been done, we can proceed to the next step. The question asks for fluid velocity. Therefore, formula that will be used to search the velocity is Q equals to AV. In order to search for velocity, we need to know the value of A and Q. Since Q has been given from the question, which is 0.175 meter cube per second, all we need to do now is search for area. Formula area that will be used is pi d square over 4, or another formula that can be used is pi r square. Substitute value of diameter, which is 0.245 into the formula, and we'll get 0.047 meter square for the area.
After we got the value of the area, which is 0.047 meter square, all we need to do is substitute it into the formula, which is Q equals to AV, where Q is the discharge through a pipe, A is the area, and V is the velocity. Then we will get the equation that is 0.175 equals to 0.047 times with V. We need to move 0.047 to the left, and 0.175 will be divided with 0.047 in order to get the value of velocity, which is 3.723 meter per second. As for the specific gravity that already has been given from the question, which is 0.78, this value will help us to determine the value of density of a liquid, where the formula is density of liquid times with gravity divided by density of water times with gravity. Since the value of gravity is the same, we can cut both of it, so it will be density of liquid over density of water. After that, for the value of density of water, it has a fixed value, which is 1000 kg per meter cube. Then substitute it together with the specific gravity into the formula, and we'll get the equation like this: 0.78 equals to rho of liquid over 1000. Move the 1000 to the left, and 0.78 will be multiplied with 1000, and we'll get the density of liquid, which is 780 kg per meter cube. By determining the value of density of liquid, it will help us to know the Reynolds number, where the formula is Reynolds number equals to density multiplied with velocity and diameter over dynamic viscosity. Since we got all the value, just substitute all the value into the formula to get the value of Reynolds number. From the answer that we got, the value of Re is more than 2000, so we can conclude that the type of flow is transitional flow because RE is more than 2000 and less than 4000. In conclusion, from the calculation, we conclude that the type of flow is transitional flow. Transitional flow occurs in the Reynolds number range between 2000 and 4000 in pipe flow. In this region, the flow is unstable since it can switch between laminar and turbulent.